Okay, guys, back for day two. This is a really cool problem. I like this guy because it's one of the few problems that you run across where there's more than one different way to do it. Okay, I actually worked it out this morning just to make sure that I could get it to work two different ways. So I'm going to show you both of them. And I would say that I think one way is slightly easier than the other. And once I go through both of them, you'll probably be able to notice which way is a little bit easier. Okay, so let's see. I've got to do a U, a DU, I need a DV, and I need a V. Okay, and remember again, we're going back. Okay, the integral of U dV equals U times V minus the integral of V du. Okay, to be able to do integration by parts. Okay, so what if we let U be the natural log of X? So if we do that, then X dx has to be your dV. Okay, so to go from U to du, I take the derivative. So the derivative of the natural log of X is 1 over X. dx dx, so it's just 1 over X. Okay, and right here to go from dV back to V, okay, remember I would have to integrate this X dx. Okay, to go back here. Okay, so I'm going to get X squared over 2 when I do that. Okay, so let's see what we got. Okay, so if I'm following this formula, okay, and so I have my U dV, okay, all right, we're going to get UV, so U times V, okay, so I multiply the natural log of X times this X squared over 2 minus the integral of V du. Okay, so it'd be V du. So it'd be X squared over 2 times this 1 over X dx. Okay, like this. Okay, so let's see, this guy right here, I would probably just multiply them together and just write that as X squared natural log of X all over 2. And then this guy right here is kind of cool because you can simplify it. Notice that you have a common, you have a constant multiplier of 1/2, so I can stick that guy out front. Okay, and then I can cancel an X down below with an X up above, so I just end up with X dx. And obviously we can integrate this guy. Okay, so we get X squared natural log of X all over 2. Okay, minus that 1/2, and when I integrate this guy, I'm going to get X squared over 2 plus my constant of integration. Okay, so simplifying, okay, I'm going to get X squared natural log of X over 2 minus X squared over 4 plus C. And that would be one acceptable form of the answer. I'd say about the only other thing I see that I might take a look at is how about finding a common denominator and combine these two guys. Okay, so if we put it all over 4, that just means I got to multiply above and below here by 2. So we'd get 2x squared natural log of x minus x squared, and then plus that c. That would be another acceptable form of the answer. Okay, and but the only other thing, I thought of when I was doing this is, notice you do have a common factor of x squared up above in the numerator, so you could pull that out if you wanted to. Okay, factor out the x squared, and so you'd be left with inside 2 times the natural log of x minus 1, okay, all over 4, and then plus your c. Okay, so you got, certainly I would accept all three of those answers. Okay, I don't think I guess you could say that maybe these two are a little bit simpler than this because you've combined things into one fraction, but I don't think it's noticeably so. So I know that I would accept any one of those three. Okay, so we go the other route, okay, and we say, okay, well, what's another way to do it? Okay, well, what if I switch the u and the dv? Okay, so this is kind of cool what happens here. Okay, so my du, my dv, and my v. Okay, so what if I let the x be my u, okay, and the natural log of x dx would be my dv. Okay, so let's suppose we go that route. Okay, so going from u to du, I got to take the derivative. So the derivative of x is just 1. So we just get 1 dx or dx. Okay, now right here, remember, I would have to integrate natural log of x dx to go back to my v. So this comes back to what we were doing last week. Okay, right here. Okay, so when I integrate this, okay, I'm going to get x natural log of x minus x. Okay, we're in good shape there. Okay, so let's see how this works out. Okay, all right, so let's see. I got this starting point, and I'm going to rewrite it, and there's a reason why. Because somewhere in the middle of the problem, I'm going to need it. There's a cool little trick that happens. Okay, so let's see. I've got my uv, so u times v, so I have x times the quantity of x natural log of x minus x minus the integral of v du. V du. Okay, so it would be x natural log of x minus x dx. Okay. All right, now this guy's, I'm going to bring him down. I'm not going to rewrite it, but I'm going to bring him down. You'll see as we get towards the middle of the problem why this guy's really important, and it's a cool little technique that comes up every now and then. All right, so right here I'm going to distribute the x. So I get this x squared natural log of x minus x squared. All right, now this guy, notice the integrand is a difference. Okay, so I'm going to split it up into two integrals. Okay, that would be the integral of x natural log of x dx minus the integral of x dx right here. Now, notice this guy right here. This is really important. Notice this guy right here is the original guy we started with. And that's why I want to continue to bring this guy down. Okay, so I'm not going to do anything with that right now. Okay, so let me bring this guy down. X natural log of x dx equals, okay, there's not really anything I can do here. X squared natural log of x minus x squared. Okay, minus this guy, and again, I'm not going to do anything to him yet, and I'll show you how I'm going to deal with it. But notice minus this, that would be plus, and when I integrate x dx, I get x squared over 2. So it'd be x squared over 2 plus c. All right, now, very cool. How about this guy? And how about this guy? Aren't they similar? So couldn't I bring this guy over and change it to plus and add it to this guy? So wouldn't that end up giving me 2 times the integral of x natural log of x dx? Okay, so that guy came over here. I'm left with this, x squared natural log of x minus x squared. I have this plus x squared over 2 plus this c. And notice right here, that guy and that guy are similar terms. So I can collect those. So I have 2 times the integral of x natural log of x dx equals x squared natural log of x. And let's see, if I add the coefficients, that'd be -1 plus 1/2, so it's -1/2. So minus x squared over 2 plus c. Now notice the original problem and what I have here. Couldn't I just divide all the way through by 2 to isolate that guy and therefore find out what this integral is? Okay, so this guy, the integral of x natural log of x dx, ends up being everything divided by 2. So that would be x squared natural log of x over 2 minus x squared, now I divide by 2, so that'd be over 4, plus my constant of integration. And how about this? That guy right there. Isn't that the same thing right here? Same exact thing, okay? And so you take a look at, okay, this guy, okay, and this guy, and I think that most of you would probably agree with me that this method here is a little bit easier. This one's a little bit tougher, but the reason I wanted to go through both of them is, number one, this is one of the few problems you run into where you have multiple ways to do it. Okay, it'll work both ways depending on, you know, what you let U be and what you let DV be to start. Okay, and it's also because of this little technique. Okay, this guy and this guy end up being similar. Okay, and bringing that over and adding it. Okay, that doesn't happen all the time. So but that does come up on numerous problems. Okay, and so having the ability to look at that early on and see a problem where it's cool, where you could do it multiple different ways, is pretty cool. Okay. All right, let's see. Where's this guy? This guy is actually relatively easy to do. I like this guy. I took a look this morning. Is it like the last one where you can do it more than one way? And I'll be honest with you, I didn't work it out. I did work it out in my head, and I know that one way is definitely easy, and the other way, if it does work, I don't think it will. It's going to be a nightmare. Okay, it's really going to be a nightmare if it works out. Okay, but I got to a certain point thinking about it in my head, and I knew that, oh man, I'm going down the wrong path trying to do it this way. So I'll show you the way that you should do it. Okay, easy way. Okay, so again, we have our U, we have our DU, we've got to have a DV, and we've got to have a V. Okay, so I know me, I'm looking at this and I have x times e to the x power. And I'm thinking, okay, if I let U be the x, then when I take the derivative, I'm just going to get dx. And so it sort of minimizes it. Okay, so I kind of like going that route. So if the x is the U, then the e to the x has to be your dv. Okay, so let's see, when we take the derivative of U, which is just x, we just get 1, so you just get 1 dx. Okay, and remember, this is the cool thing, okay, when you take the derivative of e to the x, you get e to the x, which means that when you integrate e to the x, you get e to the x as well. So when I do this, to get back up to my v, I'm just going to get e to the x. Okay, so again, u dv, the integral of u dv equals u times v minus the integral of v du. Okay, so let's see. We got to do this guy. So we go u times v. So we get x e to the x minus the integral of v du. So it'd be e to the x dx. And obviously this is pretty easy to do. X e to the x minus, Well, we already know. We already did it up here. You know, it's about as easy as you get. When you integrate e to the x, you just get e to the x. Okay, so we get e to the x plus a constant of integration. And you certainly have one very acceptable form of the answer. I'd say about the only other thing, if you wanted to do, notice you have a common factor of e to the x here. You could factor that out, and so you'd be left with x minus 1 inside plus your constant of integration. Okay, and we're good to go. Okay, so that one was really easy. Now here's the problem, and trying to think of this, you know, through your head. You know, when we were talking about, you know, this one, if you go the other way around, it's going to get tougher. You know, what if you did do this? And this is, like I said, this is what I was thinking through in my head. Okay, and I say, okay, well, why not let, if I switch the x for my u and my e to the x for my dv, and so I put e to the x here, and I put x dx here. Okay, so I take the derivative and I get e to the x dx. And then here I would have to integrate that guy to get back to v. So notice what happens is I would get x squared over 2. Okay, and so what happens is up here, when you let the x be your u and you take the derivative, it sort of diminishes it, just knocks it down to a dx. But over here, that doesn't happen, and it certainly doesn't happen here. It makes things even harder, okay? So if you went about your business here and you said, okay, if I go uv, okay, so I get x squared e to the x over 2 minus the integral of v du. Notice I'm going to get x squared e to the x over 2 dx. And then you take a look at that guy and notice it's not the same as what we started with, so we can't use that technique. And so what would happen here is you would have to go back and use integration by parts on that again. And so you see how it's just opening up this Pandora's box where it could just get ugly. And would it continue to work out? I have no idea. I just know that it's getting a heck of a lot uglier than what we did up here. Okay, so I would not go down that route. Okay, that's why this guy is such an important problem to look at, because it doesn't matter which way you do it. It works no matter what. Now, clearly, as we talked about, one is a little bit easier than the other, but at least you can do it both ways, because that doesn't usually happen. Okay, guys, that's it for today. I'll post this, and let's see, I'll probably get the quizzes together and have them posted tomorrow. Your grades from last week's quiz is posted already, so stay safe, and I miss all you guys.